Hello, my name is Beatrice Klink, and for my final project in the Soils for Life course, I'll be talking about a soil degradation disaster in Brazil's capital city, Brasilia. Residing in Brasilia, my home's domiciliary waste, like all others, is transported to a nearby dump site called Lixão Estrutural. Receiving daily more than 9 tons of waste from Brazil's capital and all of its surrounding administrative regions, Estrutural has become the largest dump site in all of Latin America and one of the largest in history. Thus, in contrast with landfills, dump sites do not use any soil or water protection systems. So either geosynthetics, they don't drain the slur, and don't treat the slur as well. There's no soil compactation and also no production of biogas, therefore relying on basically no contention methods in order to prevent soil degradation as well as groundwater sources pollution. Located amidst a high-altitude plateau, approximately 1,000 meters above sea level, the federal district's climate is seasonally tropical, having an extremely dry season with relative moisture reaching 8 to 12% and an extremely rainy season, having rainfall of more than 2,000 millimeters annually, concentrated in only 4 to 6 months. Due to the geological formations of Brazil, the soil is mainly constituted of sand and clay. The continuance of waste deposition in lixão estrutural is extremely dangerous for the local population, for there is risk of contamination in underground water aquifers, soils, and thus food sources, as well as spreading the diseases. Although there is much protest to shutting down the site or even proposing the correct solution, the execution of a controlled landfill on the site, mitigating the possible environmental impacts is very hard. Being based in an area severely stricken by poverty, at least 5,000 families rely on the dump site to survive. By consuming wasted food and selling recyclable materials, the lixão provides their subsistence. In that sense, it is a very difficult problem to solve in a sustainable way. The social impact of ending the site would be catastrophic. As seen in a case study in Gramacho, Rio de Janeiro, where more than 8,000 families lost their only means of survival when their local dumping site was converted into a controlled landfill called Seropédica. Not receiving the correct governmental assistance, these people were severely neglected. However, the continuance of waste deposition poses as a humongous threat to many other stakeholders, such as local farmers, populations that use the water from the same aquifer that stands below the site, the government, therefore needing public policies to improve those families' lives and prevent the spreading of endemic diseases such as dengue, Zika, chikungunya, and others. Also, waste management companies that are looking to turn the site into profitable biogas production landfills. The future prospects for the area are extremely severe. Aside the imminent risk of water and soil contamination, the social and ecological impacts are grave. The continuing soil degradation and contamination will instill even larger water supply and crop pollution. In order for the mitigation of the local soil degradation issues, there would need to be a swift governmental investment, modifying the dump site into a controlled landfill. In contrast with a dumping site, a controlled landfill uses usually 3 layers of geosynthetics. First, a geomembrane, which is in direct contact with the soil, and it's protecting the soil from mechanical as well as chemical damage. Then, a geotextile to drain the slur, followed by another geomembrane layer to protect the geotextile, as well as a correct drainage system to collect slur lodged in the geotextiles and send them to the treatment pools in order to treat the slur and contaminated water. Therefore, ceasing to degrade the soil would significantly improve local water qualities, making it available for human, industrial, or farming consumption. Thank you for your time.